Welcome back. We're going to continue on with how to do some amazing art using SwiftUI and drawing with Swift. Today we're going to be looking at how we can do a spirograph view. You may have played with this game or a set of coloring toys as a child or even as an adult, and so you can draw some really cool shapes and functions simply by connecting a lot of straight lines together using a rotation of a circle inside a circle, aka hypocycloid is the mathematical term we're using to actually make that happen. But in order to make that happen here in Swift, we're going to go ahead and make it so we can draw them right here. It's really just basically an application of math and Swift to create art. So let's take a look at what we're doing right here. The first thing we have is a struct spirograph view, and of course it's the same thing. We're using a SwiftUI file, how to do all of the stuff we've been working with so far. Inside that var body, I'm making a Z stack so I can layer my things on top of each other just like normal. And so I have a spirograph with the default value. I have a spirograph where I'm passing it some parameters and setting its color to be green, and a third spirograph, where I'm passing a different set of parameters and setting it to be red. As we look over here on the screen, we can see we've got the blue, the green, and the red spirograph examples, so we can see what's going to happen as we send those different parameters and what's going to make them work the way they're happening. So let's first take a look at using the default set of parameters right here with a stroke, where I'm just simply creating a spirograph with no parameters to it, making it blue and a line width of 1. So the spirograph shape is really just a function of both sine and cosine combined together. That's all we have to do to make that happen. It's how you take an inner circle and an outer circle, you're drawing around in it. You may have played with the toy as a kid, you know what I'm talking about. And so with that spirograph shape, we have a couple different parameters we're working with. We have some bars on here, some data members that belong to the spirograph. So the first one is a shift. It's a double. It's how far off from the center we're going to be talking about, so the shift amount. The next is an increment. How much are we going to change each time as we go through our loop? The repetitions, how many times are we going to actually repeat this process? And then we have our large and small radius, referring to the circles we're talking about when we're putting the big circle and the small circle that's rotating inside it. So that's what we're talking about with right here. And those are all double values. I started them off in this case with a 20, 0.5, 360.0, 10, and 17. Now those values can be as big or as small as you want to play. You can see some really cool effects. We'll see that as we actually trace through the method and go along. The first thing, of course, because this spirograph is a shape, that's the protocol it conforms to, it has a required method of funcPath in rec cgrec that returns a path. Again, anytime you're working as a shape, you have to have that method inside there. Now again, when we're starting off with that path, we make a variable. I'm going to call my nifty path because it's a really nifty thing to do. And I know, silly. And so I'm going to say, first my var current x is set to double of rec.midx, and my var current y is double of rec.midy. So I'm giving myself to start in the origin, the middle of my screen. Then I say nifty path, I'm going to move my spot to that very middle of the screen. So that's where everything I am starting off with starts off, is in the middle of the screen. And then I use for theta in stride. Now theta is the term that we're using for that change in degree over time, is what we're working with that. So the dt over that, if you're looking for a nice little math term to refer to. And then in stride means, hey, here's the space I want to go over. This is a way I can do a specialized type of loop. And so the in stride means I want to go from 0 to this repetitions amount and by this increment. So this is how I can do a semi-traditional for loop using Swift, because Swift does not support the C-style for loop anymore. And so that for in stride is the closest thing we have to a C-style for loop inside SwiftUI. So inside that, I'm using the let keyword. Again, remember the let keyword is how I can create a temporary constant. It's a one-time assignment variable. And so I'm going to get that for both move x and move y. And for each of them, it's just a little math equation. For the x value, I'm going to use the cosine of theta times the value of the large minus the small radius, so the difference in radiuses, or radii. And then I'm going to add to that the shift value, aka what I'm shifting off of the origin point. And then on top, multiply that by the cosine of the small minus the large radius, and then times the theta of the small radius. So I'm inverting that right there. So I have this really cool little pattern right here. So I have the cosine of that, and then I have on my move y, it's the sine value instead of the cosine of large radius minus small radius plus the shift times the sine of the small minus the large radius, so the negative difference, and again times theta of the small radius, theta over the small radius, so the difference, the resulting quotient of that. And then I assign those values. So my move y is assigned to plus equal current y. So I'm going to take my current y and add that small little shift to it. And my current x is going to add that small little shift of move x to it as well. And then I add that line, that tiny little line I just made from CG point, from that current x to that current y. So making those tiny little lines over time and repeating this that many times from 0 up to that repetitions amount by whatever increment I specified. And so that first one right here, using color blue in line with 1, is just the default values of 20.5, 360, 10, and 17. My second one, the one that's using green, I set my shift instead to be 14. My increment is now 5.3, so that increment is going up by 5.3 times, so it makes a different increment or jump each time I iterate through my loop. My repetition is 352. Why not? My small radius is 0.3. My large radius is 218.2. And I make that one green with a line width of 2.1, so it's a little bit thicker. And then my last one, my shift is only 3. Increment goes up to 3.1. My repetition's down to 200. My small radius is 20, and my large radius is 221. And I get this cool star effect happening. So you can do some really cool effects by simply changing the parameters we send to this. This is one of the ways you can see amazing different parts of creation. By simply changing the parameters to your method, you get new results, because by supplying those small changes to it, it changes the actual values that you get for the sine and cosine values, and it makes some really pretty art. And so this is a great way we can integrate math and creativity and art into a single programming project, and we get some cool views like this. Again, take some time to play around with this, change some of the functions or the equations that happen with that, and you can do some really cool and creative work. And so I highly encourage you to try this out and have some fun. Thanks again. Cheers. Bye.